Okay, so this is the second problem. So we have y prime plus y over x squared equals to 2x e to the 1 over x. And we're given an initial condition that when x is 1, y is equal to 13.86. So once again, let's identify what kind of um, problem do we have here. And if we see this, once again, let's check. There, all the powers are 1 of the y's. There's 1, there's a power of 1. Don't worry about the power of x. We're just focusing on the power of the y's. So since all the power of the y's are 1, so they are linear. And what kind of linear? Well, let's check then. Um, do all the terms have a y on them? Well, it is a y. This term has a y. This term does not have a y. So that means that this will be a linear non-homogeneous. So we know how to solve that one. So once again, we identify there's first what p of x will be. And in this case, the term with the y, p of x, will just be, if we ignore the y, it will be just 1 over x squared. And then the term r of x will be 2x e to the 1 over x. So you can see I told you in the last example, these were numbers. In this example, they're functions. So they can be function or constants, either or. This problem still applies. So now that we know that, let's find h. And h, once again, is the integral of p of x dx. So this will be the integral of 1 over x squared dx. And we're going to take this integral. So, and no, this integral is not just ln of x squared. Don't fall for that trap. If we do this one, we can do x to the negative 2, right, dx. And then if we do the integral, right, the integral for this, we add the 1. So it will be x to the negative 1 over negative 1, which you can rewrite as negative 1 over x. And this is our h. So make sure that you will follow the rules of integration. Just because it's 1 over something doesn't mean that it already is ln of that thing. Okay, so now we have that, we can find our y. And then we know that y of x is equal to e to the negative h times the integral of e to the h times r of x dx plus c. So plugging all of that in, we then get that this is equal to e to the negative negative, so that will become positive 1 over x times the integral of e to the negative 1 over x times 2x. I'm just going to use other color so you see where that comes from. 2x e to the 1 over x dx plus c. And we're going to continue simplifying, and what you can notice is that the things on the inside the integral, they will cancel out because they have the same power. You can see we have e to the negative 1 over x, and we have e to the positive 1 over x. So these two terms, once again, they have opposite exponents. They're the same, but just opposite power. So basically, they end up canceling out, and all we are left with is the integral of 2x dx plus c. And to do this, it's pretty simple. So this is e to the 1 over x times the integral of 2x, that is just x squared plus c. Once again, we are going to distribute the outside times all of this and inside the parentheses. So let me just mark it here. So e to the x times x squared and times the c. And then our solution, y of x, is just e to the 1 over x times x squared plus c. That's just we can distribute it. Right, we can write it as um like how it is distributed, right? So which will be x squared times e to the 1 over x plus c times e to the 1 over x. But it just looks cleaner if we leave it like this. Since it's the same term on both of them, it looks cleaner, at least for this specific problem, to leave it like this. But we are not done yet. You can see we're not done. We were given an initial conditions. And so once again, this will be our general solution. This is our general solution. And since we were given an initial condition, we need to find the particular solution. So let's apply that. So we're going to apply the initial conditions. So apply initial conditions. And initial condition states that when x is 1, y is equals to 13.86. So let's find that out. So we have over here then, let's plug in that. So we have 13.86, and that will be equal to e to the 1 over 1 times 1 squared plus c. All right, we want to find out whatever that c is. So then this becomes 13.86 equals to, well, e to the 1 over 1. That's just the constant e, which you can find in your calculators, times 1 plus c. And once we distribute this, we can rearrange some of this. So for c, we'll get that 13.86 over e, right, and then minus 1 should give us our answer. All right, so whenever we solve this, we have then that c, it's equal to about 4.09, or you can round out to 4.9, I mean 4.1. Right, we can round up, let's say 4.1, and then our particular solution for this problem will be y of x is equal to e to the 1 over x times x squared plus 4.1. And this will be our particular solution. So once again, this was a problem regarding linear non-homogeneous first order ODEs. Pretty straightforward. It's just plug and chug, nothing too complicated. We'll do an example of this, like a practical application, and then we'll cover a video regarding nonlinear ODEs. That's it for this video, and as always, good luck.